Tomorrow will be better. Why does water vapor at 100 degrees feel hotter than boiling water at 100 degrees? This is an observation so many of us have made, but not many can explain the science behind this observation. Follow me, dear friends. Solution. To ease your understanding of this phenomenon, I will take a sample of water at an initial temperature. Now, let's take two samples of water, each at an initial temperature of 50 degrees. Initial temperature 50 degrees. Now this is sample 1, this is sample 2. Now bring these two samples of water at the boiling point, which means heat it up to a second temperature, 32, which is 100 degrees. 32, which is 100 degrees. To do this, we will need to supply a certain quantity of heat, Q1, which mathematically is given by, Q1 here will be given by mc delta theta, where m is the mass of the water, c is the specific heat capacity, and then the change in temperature. Now, one of the samples needs to be taken to the vapor stage. So, I will take it now to a vapor stage of 33, which is still 100 degrees Celsius, but now it is in the vapor state. For this to happen, we need to input another quantity of energy, this time around Q2, which this time around will be given mathematically by Q2 equals mLV, where m here is the mass of the water, and then LV rather is the specific latent heat of vaporization. Now look at something. It is therefore evident that this second sample of water, which indeed is water vapor, will be hotter than this first sample, because in addition to Q1, which both samples already had, the sample 2 has an extra energy, Q2, for it to get to the vapor state. Now, a lot of you will be asking me the question, how do we input a second quantity of energy and still have the same temperature? This explains why we call it the latent heat. Latent heat means a certain heat which is inputted but doesn't cause a rise in temperature. Okay, the word latent here can be translated into English as hidden. Okay, so specific latent heat is a hidden form of heat which, though in reality goes and causes effect, but in reality does not change the temperature of the object. This is why this sample here of vapor at 100 degrees will burn or will feel hotter than this first sample of boiling water at the same temperature of 100 degrees Celsius. Tomorrow will be better.